Okay, so we're taking a look at some exercises and examples from section 3.3. So in 3.3, we want to remember two of the limits, right? The limit as something goes to 0 of the sine of something divided by something equals 1, right? And the limit as the something goes to 0 of the cosine of something minus 1 over over something equals 0. And the reason I'm writing this in this weird way is that in order for this limit to actually work out, whatever appears in this argument has to be the same thing, has to be the same expression as you're getting in the denominator, right? And so that's the pattern that you have to match. And so similarly here, the pattern here is that these two things have to be the same. Okay, now this may be a little bit different. For example, well, we'll see in just a second. As long as this expression is going to 0 when whatever variable is going to 0, then we're fine. But it's really the key part here is that these patterns have to match. What I mean by that, if we take a look at one of the examples, we want to compute the limit as x goes to 0 of the sine of 7x divided by 4x. Okay, now the problem is that this is not of the right form, right? And so the trick is to use a little bit of algebra, and I'm going to multiply and divide by the same number. Okay, now what do I have to put here in order to get the right pattern? I need a 7x to appear there, right? But if I put a 7x in the denominator, I have to multiply by 7x as well, just to balance the fraction out. And now I've got the right expression, right? So I can now take the limit as x goes to 0 of this times the limit as x goes to 0 of this. These x's cancel. This limit goes to 1, right? And then overall, then the limit is equal to 7/4. Good. So be careful of the little algebra trick here. Let's try another problem. This is number 9 in 3.3. Let's say y is equal to x divided by 2 minus tangent x. So what will y prime be? So y prime is going to be a quotient rule. And so we take the derivative of the top times the bottom minus the top times the derivative of the bottom. So the derivative of the bottom is 0. And then the derivative of tangent is secant squared. So that's going to be minus secant squared, all divided by 2 minus tangent of x squared. Good. So like I said in the last section, if most of these problems, I'm just going to ask you to write down the derivative. Later on, we're going to be needing to simplify this in order to solve for where the derivative is equal to something, for example. But for now, it's okay if you leave your answer in that form. Let's try number 13 in 3.3. That's y equals t sine t divided by 1 plus t. And so what will y prime be? Okay, so y prime is going to be the derivative of the top. But notice the top itself is a product. So what I might do is I might just say this is going to be t sine t prime, right? Times 1 plus t, so times the bottom, minus the top, times the derivative of the bottom, which is just 1, all divided by the bottom expression squared. Okay, and so now I can take a second step, right, and take the derivative of this product. And so the product there is going to be the derivative of the first function, which is 1 times the second, plus t times the derivative of the second, right? And then I'll have my 1 plus t there. And then we'll have our minus t sine t divided by 1 plus t squared. Good. This probably simplifies a little bit, but like I said before, we're not going to worry about the simplifications too much at this point. Let's try one more, just because I think it's worthwhile to see kind of an extension of some of our work before. So if g of x is equal to x e to the x, cotangent of x, find an expression for g prime of x. Notice that this is a product of three functions, right? So g prime, so you can group these any way you want. I'm going to group the x and the e to the x together. So this is now an expression of two functions. And so when I take the derivative, I can rewrite it as x e to the x prime, the derivative of the first function, times the second function, plus the first function, times the derivative of the second function. And I could even write that as cotangent prime here, just to remind myself what I'm doing. Okay, and so now we can simplify everything. The derivative of x times e to the x we get by using the product rule. So the derivative of the first times the second plus the first times the derivative of the second. Right, and that's all times cotangent of x. And now we have plus x e to the x. And now we write down our derivative of cotangent, which is, did you have to look? Minus cosecant, I guess you can't really see it anymore, cosecant squared x. Good. And so, by the way, just did you notice what happened here? If you were to multiply this out, if we take the derivative of a triple product, right, what happens is you end up, it looks very similar to the other one. You take f prime times gh plus fg prime h plus fgh prime. It's kind of fun. Okay, so I will let you work through the other problems in 3.3. We won't have any drills for this section. We'll come back to some drills in after section 3.4 when we get a couple more theorems. All right, see you then.